Hello, students. Let's have a moment of science. We are going to be doing a lab today about weight and the spring scale. This is my first lab recording, so bear with me. I might make a few mistakes, just like I just did. But just like any great scientist, we learn just as much from our mistakes as from the things we do right. So in this lab, I've got my graduated cylinder. I've got a flask of water. I've got my spring scale in my empty milk jug. Okay. I am going to be testing to see if we can answer this question. The question is, if we were to keep adding equal amounts of water to a milk jug, which again, any container, will the weight of that container uh, increase by equal amounts? So if you could, please pause your video right now and write down your hypothesis. You're going to write your hypothesis as an if-then statement. What I mean by that is an if-then statement is basically if this happens, then this is going to happen. Okay? So for an example for this one, if I add equal amounts of water to a container, then then the weight will increase by equal amounts, or then the weight will not increase by equal amounts. Whatever you think is going to happen. Okay. So pause the video and get a chance to write down your hypothesis. Now, again, I told you we're going to be using this graduated cylinder for measuring the volume of the water. We're going to make sure we use the exact same volume of water for every time. We're going to use 50 milliliters. And we're going to use the spring scale here to measure the weight of the milk jug as we add more and more water to it. Right now, I've got it set up so that it doesn't even have the weight of the milk jug in it. So right now it's at 0 newtons. And then as we add more water to it, we're going to figure out how much that would weigh, and I'm going to record it on my paper over here. At the end of the video, I will have all of the data on the screen so that you can use that to answer any questions I ask of you. Okay? So here we go. We're going to put the water in the graduated cylinder. We're going to try to be as accurate as possible. If you've never used a graduated cylinder before, there are little lines on it telling you how many milliliters are in there. And then you look at the bottom of the curve of the liquid to make sure you have exactly the amount you need. So I'm going to hang my container and I'm going to pour my water in. And then I'm going to take a look and see how many newtons it is. And I'm going to write it down. Any good scientist is always going to be recording their data to make sure that they can take a look back at it later. And then we're going to do it again. We're going to get the exact same amount. That time I had just a little bit too much. So I'm going to put a little bit out. And we're going to go for this thing again. And we're going to record our information. As I'm doing this, I have asked you a few questions in your work about the devices that I'm using to measure the volume of the water and the weight of the water. If you could, while I'm doing this, answer those questions about the devices and about the units of measurement for each one. And you are writing down the questions or the answers to your questions about the devices and what units of measurement each one of them uses. I have already mentioned them in the video, so that should give you a pretty good idea of what I'm doing and what I'm using. Now you'll notice that I have already done this 4 times. Okay? And you might be wondering, how many times is he going to do this? This is not very entertaining watching me pour water into a jug. Okay? I'm going to ask you that question. Why am I doing it so many times? I'm going to be doing it 10 times. But why? Why am I doing it so many times? After a few more times, I'll tell you. But I want you to think about that question yourself. Why am I continuing and continuing? Why didn't I just stop after 2? Again, I will be putting the data that I'm writing down at the end of the lab so that you can have that information to answer your questions. Figured out why I'm doing it so many times yet? Well, here's why. Scientists know that the more times we do something, the better results we're going to get. You've learned that in science before, in your previous years. This is to reduce bias. This is to make sure our information is as accurate as possible. Scientists don't just do it a couple times and then be done with it. We do it as many times as we can to make sure we have as good of information as we can get. Think about it this way. If you're flipping a coin, and you flip it twice and you get heads both times, does that mean that every time you flip a coin, you're going to flip a heads? Definitely not. Of course not. You have 2 sides. You have a 50-50 chance of getting heads or tails. Just because it happens twice does not mean that it's going to happen every time. And the same thing with pouring this water into this milk jug. It's not going to happen the exact way every time. You'll notice that it's got a pattern going, but towards the end of my data, the pattern changes a little bit. And it's your job to determine, is that change enough to change the answer to our question, to our hypothesis? So, I've gathered my data. I've finished my experiment. I've done all 10 pours. Thank you for paying attention through it. I know it's not the most entertaining thing to watch me pour water. But you're going to use the rest of this time to answer the questions at the end of this lab. You're going to use the data that I'm putting on the screen right now to make sure that you understand, did the weight of this jug increase equal amounts every time I poured, or did it not? On average, did it change equal amounts? Did it not? And you're going to be able to explain that using the information I gave you. Thank you for watching, and next time we'll have another moment of science.